actually the Amazon App Store. And it's a title that's a little hard to sometimes. It means I'm part engineer, I'm part marketer, I'm part customer service or user advocate, and I tend to focus on mobile and mobile games, but that includes a chunk of the work that we do with mobile developers who are making the transition to streaming media devices. So today I'm going to talk a little bit about that intersection and why we think it's an interesting opportunity. I'm assuming that most of you, if you're here today, have at least heard of the Amazon App Store, even if you maybe haven't published your apps with us, or at least you haven't published with us yet. But if not, it's how users of Amazon devices actually get access to Android apps and games, because it's the App Store that comes pre-installed on all of our devices, right? So it's not limited to Amazon devices. Actually, you can install it on any Android device. You just need to install our store, and then you have access to our entire catalog. And just like our retail website, the Amazon App Store has this vision, and it's a vision to delight customers by connecting them with content that we think they want or that they might want. And that's what this talk is about, connecting the content creators and the content consumers in new and innovative ways, specifically on hardware that is growing in popularity every day, and many developers may not even realize that they have ready access to it. So tools like Unity obviously make releasing to these kinds of devices actually very straightforward. They work right out of the box. So we see streaming media devices as this great new potential opportunity to reach new customers and increase your revenue, and we see Unity as this clear, well-lighted path toward that goal. And we'll see what that means toward the end. This is a short talk, mainly because the technical component is so straightforward, I think. For most app developers, learning how to think in terms of the living room audience is actually a bigger issue. It's a larger challenge. So I'm going to include a bunch of practical details about how you can tailor the customer experience to streaming media devices. And let me answer the basic question first, which is, why even bother developing for these streaming media devices if you're not a video app? I mean, they're primarily designed for Netflix and HBO Go or HBO Now and BBC Player and ITV and probably Amazon Television, Amazon Video, right? Of course, they definitely can handle that, but there's really so much more that they have to offer. Now, if you haven't really looked at these gizmos as a launch platform for your app or your game, maybe you haven't seen their sales numbers. And I think if you were in the keynote, you probably got a little bit of information about how they're doing. And I mean, streaming media is really, really popular, and streaming media devices obviously expedite delivery to the most popular screen in the house, right? Talking about TVs. TVs in the living room, TVs in the family room, you know, wherever everybody gathers for Game of Thrones night, or when the kids have a sleepover, or when you just want to kick back on your lunch hour when you're working from home. My mom has one, so you know, she loves her Fire TV, and she's not actually the only one. Amazon Fire TV and Fire TV Stick represent two of the biggest reasons that I'm here talking about streaming media devices, of course, because you know, we make two of the most popular ones available right now. So of course I want to help developers be successful on them and build on them, and these things are just getting more and more widespread. They're more popular than ever, and it just so happens that the hardware in the Fire TV, at least, is also highly capable. So not only is it a great development platform, it's also based on Fire OS, which is based on Android, which makes it remarkably easy and straightforward to bring your existing Android apps to the hardware. And why wouldn't you do that if you have this opportunity to increase your potential audience? And if I still haven't convinced you, just look at our last Prime Day. This is a little sales extravaganza we run every summer, and this year we sold 2.5 times as many Fire TV devices as we did last year during the same day. So it turns out the Fire TV Stick was actually the best-selling Amazon device. And you picture all the customers unboxing this cool new toy and setting it up and checking it out and seeing what it can do, and your app is right there ready for them to use, and check out on the big screen, right? Or not. Wah, wah. Too bad. Well, like I said, it's remarkably easy to bring your Android app or game to Fire TV, and at the very least, then you benefit from this rising tide as the installed base grows, and potentially you expand your reach to a whole new audience.
Was that bundled with the controller? The game controller, your figure?
Oh, no, that does not include the game controller. So there's no question that these devices have video handling at their core, right? This is what they're good at. It's part of the key to their success. But the fact is that these devices actually pack quite a lot of power in a small form factor. And they're equally at home, no pun intended, running processor-intensive applications or apps with increasingly demanding memory requirements. So they support, in this case, 4K video for the Fire TV and up to 7 Bluetooth controllers connected at once. So it's a beefy little box. And even the miniaturized version, the Fire TV Stick, and I'm sure you've all checked your swag bag, right? So you know that you actually have one of these. It supports full 1080p HD, and it's got a dual-core CPU. So, it's beefy on its own right. And in fact, we just announced the new version is going to have a quad-core. So, these are devices that both sport GPUs or dedicated graphic processing units, and you can see why I hold them up as a potential platform for your app, whatever it is. These devices are snappy, they're responsive, and they offer a great user experience. And what happens when you combine that hardware with the Amazon App Store? Remember, that's how customers actually get access to our devices. And maybe it's not a surprise, since selling is kind of sort of mostly what we're known for, but it turns out that we're actually really good at reaching customers who are willing to buy. And you think, this slide just provides one example of the mobile gamers that use the Amazon App Store. 64% of them are going to be purchasing something. And that compares pretty favorably to mobile users in general, which is only about 41%. And to highlight the results on another, I won't say competing app store, but an alternative app store, it compares favorably. Now, if you want to maximize your chance of success, there are a few best practices that will definitely help you make the greatest impact. Mostly they come down to making smart design choices with respect to the big screen. The biggest screen in the house, right? I mean, the TV is the biggest one that you'll find there. And you may be of two minds. You may, on one hand, be thinking, well, I don't want to have to make changes to my app. I don't want to redesign it for a different platform. It seems like I would have to do that if I wanted to target these devices. But on the other hand, you may be thinking, well, what's the big deal? Is there more to it than just making it run in landscape mode? And I guess I would say it just depends. It really comes down to a shift in perspective, and it's a shift of perspective from a development point of view away, right? You need to move your user away from the app. 10 feet is what we typically point to. And the reason is pretty obvious, obviously, because 10 feet is generally how far people sit from a television, which is completely different from the experience they might get 2 feet away when they're using a computer monitor, or the typical 1 foot experience that you achieve on a mobile device. But practically speaking, what does this mean? Mostly, it just means focusing on simplification. It means adjusting your approach to the user interface, if necessary, to make it as simple, as efficient as possible. It means considering using larger fonts to reduce eye strain, or just eliminating text as much as you can, just in general. It means eliminating extra button clicks and navigation and deep menus. And none of these are new ideas, by the way. They're just techniques that you would typically find referred to as the user-centered design. And they're well known and considered fundamental to that kind of approach. It also means designing the navigation to have a more remote-friendly aspect. And by this I mean it's easier for the user to interact with your app using a simple candy bar remote, right? So that's the one that ships by default with Fire TV. And it's funny because here's something that game developers have actually been doing really well for about 35 years. They've been designing for a joystick or a D-pad plus a few extra buttons. And then accelerometers came around and touch screens, and they started offering all these whole new input methods. And it turns out that for streaming media devices, at least, the old ways still offer a lot of utility and value. And in fact, they haven't been completely forgotten. They've evolved to include dedicated navigation buttons, standardized now in Android, so home and back, and you can take advantage of that. And be sure that if you do, you make sure that the media buttons control media functions, just to make sure their behavior is intuitive and expected. User-centered design means that you need to try to anticipate what user interaction is going to look like, so in order to minimize the work they have to do. If you expect or you know, for instance, that most people buy one item and then return right back to the main activity of your app, then pre-select the continue button after their purchase. Make sure that left, right, up, down inputs move the highlighted selection in a logical way. Don't ever force the player down a navigation path that they can't back out of. So this is not as far-fetched as it seems. I've seen a lot of apps that try and fail to be super smart about the on-screen navigation and figure out, physically what's to the left or right of the currently selected item, but then screw up the math and end up depositing the user on a button that they can never leave. Obviously, if you're dealing with touch or even a PC with a mouse, this isn't an issue. The user can just click directly on what they want. They can free themselves from this cul-de-sac. But with cursor navigation, it can be tricky. So these are the issues to keep in mind when you move your app or game from mobile to desktop to streaming media device. And chances are, if it runs primarily in landscape orientation, it'll probably work just fine in TV, provided that you take a page from the old school gamers I was describing and make sure to provide these clear button states so you can show exactly what's highlighted and enabled and disabled. Make sure that you have that easy up, down, left, right UI navigation and some kind of simple D-pad-like interface. And then obviously, if you're on Android, you can support the standard Android back home navigation, or just make sure that you have clear indicators of how to move between screens. Next, with respect to the physical display hardware, let's talk about TV resolution and what that means for your app as you migrate it from mobile. The good news, on Fire TV at least, is that you probably don't have to do anything special to support the native resolution displayed on most televisions, at least. That is, you can follow the standard Android practices for screen density and resources, and the OS will automatically handle the rest. In fact, because of this, I typically recommend that you simply build everything for a single resolution, 1080p, which is in Android indicated by XHDPI, and that's because on the Fire TV at least, it will automatically downscale your app to 720p or 480p if it needs to, which is nice. On other Android-based TV platforms, you may have to provide resources and resolutions besides that 1080p, simply because downscaling may not be handled automatically. But Android makes this super easy, and it's actually one of the nice features of the operating system, how it handles resources in general. So you can create different layouts and drawables as necessary for each target, and you can get a ton of information about this directly from the Android developer resources, that link. Of course, orientation is another aspect of the device display that may be important to your app. And I mentioned that if it runs in landscape mode already, it may simply work without changes. If you mix landscape and portrait, though, or some things only happen when the device changes orientation, then you may need to make some changes, or at the very least, you may need to verify that nothing breaks if the orientation doesn't change, right? Since streaming media devices are never going to change their orientation. You can always query the current orientation, of course, and on the Fire TV, these are the values you're going to get. But again, you just need to ensure that your app doesn't break if the orientation remains fixed, because you can't rely on orientation change notifications to prompt action in your app. Two other quick points I'd like to mention with respect to TV displays and migrating. First is this idea of overscan, and this is the physical space that TV manufacturers reserve around the displayable area of the TV screen, and something you should be aware of when you're targeting streaming media devices, because this space can exist on TVs of any size, and it limits the area in which your game or app is able to render its UI. It can be negative if the television isn't adjusted properly. So it will actually eat into the displayable area. And I recommend that all critical UI elements simply avoid the outside 5% of the screen just in case. Keep them in the safe zone, basically the 90% left and right, top and bottom, and that way you reduce the likelihood of encountering any issues due to overscan. Second, you should be aware that TVs tend to display colors differently than most phones and tablets. So TV screens typically have much higher contrast, so colors tend to appear more vibrant and saturated and just plain brighter. The color gamut of TVs is generally smaller as well, which is just another way of saying that TVs usually are capable of displaying fewer colors than most computer monitors or mobile devices. And then cool colors like blue or gray, purple, they tend to work better than warm colors like red or orange because those will bleed on a television. So a good rule of thumb is really just to avoid oversaturated colors, that is any RGB value over about 235, and also that includes large areas of white or off-white in your screen. Okay, so we've got some ideas about how to approach UI and the 10-foot experience, and we've seen some specific examples of how TV displays physically differ from mobile and desktop. What if we find that our app does need adjustment? Are we doomed to creating multiple builds, targeting all these different various platforms? Well, not necessarily. We can use an idea that's been explored at length in the world of web development, which is responsive design. And this allows us to release one executable derived from a single code base that, in theory, will work seamlessly across multiple target devices. For the most part, responsive design comes down to screen size and resolution, which we've covered a bit already. The responsive part, though, comes in when we want our app to dynamically adjust to the capabilities of the device where it's currently running. That is, rather than hard code resolution for each specific target, we just program our app and then adjust it on the fly based on the hardware it detects. And this isn't as bad as it sounds because we don't actually have to program for every possible resolution. We can use aspect ratios instead. And you may ask, well, how is using aspect ratios any better than programming for resolutions? And you'd be right to ask that, because it's better because screens of widely varying resolution may actually share the same proportion. That is, the width and height may be relatively the same when different screens are compared. So that means that there are potentially far fewer sizes to support. We can simply target each major aspect ratio instead, since most resolutions will then be a scaled up or down version of them. So take this work in progress as an example. This game, which was developed in Unity, is designed to support multiple aspect ratios, as indicated by these colored rectangles on the outside. And it's a simple matter for us to detect at runtime the physical size of the viewport where it's being displayed and then zoom in or out of the scene to scale the game display appropriately. I mean, there's math involved, but it turns out the computers, even these streaming media devices, tend to be pretty good at math, so it actually works out. Basically, in 2 lines of code, I could make our game use responsive design. And frameworks like Unity make this super easy to test. We can play the game at whatever aspect ratio or screen resolution we want, verify that it adjusts its viewport appropriately, and then even have it change the size or position of UI elements to account for different screen layouts. So another aspect of making your app responsive is dealing with user input. And I already mentioned the importance of clear UI, user-centered design, how supporting a simple controller might exercise some design muscles, maybe that you haven't used in a while. Well, what happens when you want to move from a mobile touch interface to a D-pad remote interface and keep the same code base? And I won't sugarcoat this or gloss over it with hand wavy, like this is no big deal, or don't worry about it, or it's super simple, because it's not necessarily super simple. And in fact, designing a game or an app to work well with a radically different input mechanism is actually non-trivial. It's a non-trivial exercise, and it may be the hardest part of migration to a streaming media device. giving up the touch interface that you've come to rely on. It's not impossible, though, either. And I've seen it done well, especially when game developers take advantage of the Bluetooth controllers that are available. Often, a touch interface is designed specifically to mimic a dual stick controller. So in those cases, obviously, migration is actually trivial. Regardless of the input method, though, if it does differ by device, the least you can do is tailor your help screens and tutorials accordingly. Your players will thank you. Now, detecting the current hardware actually is super simple. The system info object exposed by Unity has a property called device model, and you can query that to determine whether you're running on a Fire TV stick or a Fire TV or something else, and then you can make runtime adjustments based on that value. More generally, just to sum up the concept of responsive design and how you can apply this to games, there are three basic characteristics that typify this approach. And the first is just having the game graphics and the UI support multiple resolutions dynamically, having the game mechanics work across multiple kinds of input methods, and then being able to publish your app from a single code base. Okay, last but not least, I told you I'd walk through the technical details of getting your Unity app or game onto the actual Fire TV device. And I also mentioned that it was fairly straightforward. I might even venture to say it's rather anticlimactic, simply because the beauty of the tech these days is that it's super powerful, it's ready to go, it's right now, and it's just waiting for you to run with it. So there are only 3 steps. Step 1, actually build for Android. So you just need to export for an Android device. And as I mentioned many times, the Fire TV and Fire TV Stick run Fire OS, which is based on Android. So when you compile your application, you just need to make sure that you create an Android APK. And this is true whatever platform you use, actually, whether you're using Cocos 2DX or Unity or Marmalade or whatever. Just create an Android executable as you normally would for any other Android device. Step 2, you need to enable the development options on your Fire TV device. Again, this is strictly housekeeping, right? You just need to make sure that the actual devices will allow you to upload development code. And the beauty of the Fire TV and the Fire TV Stick, or at least one of the beauties, is that the actual devices, the ones that people have in their homes, are amazingly affordable, right? So you don't have to spend hundreds to get the hardware in order to support it. You can just get one of these retail devices for next to nothing, turn on these settings, and boom, you've got a development kit. So you need to go to Settings, Systems, System Developer Options, and actually you don't even have to spend anything now, because if you have a goodie bag, you have got one of these devices in your pocket. Turn on ADB debugging, enable apps from unknown sources. Now you can upload your app to the device. And on Fire TV, you'll also have the option of debugging over USB. This is not available for Fire TV Stick, but you can do USB debugging over the wired version. And I'm going to, for this example, just use Wi-Fi because that's how I like to connect. I'm used to it, and it doesn't use up a USB port on my machine, so you can tether with a cable if you want, but I don't like to do that. Besides, connecting to Wi-Fi isn't that difficult. Again, it's just going to System Settings and then choose About. You need to have your network up and running already. I'm assuming that you already have that going. You've got your Fire TV connected to the network. Maybe you're using it yourself to stream media or run apps. So it's just a question of finding its current IP address, which is listed under Network as the first property, and you just need to make a note of that value. Then use ADB to connect your development system to it, and you're live. That's all there is to it. So, like I said, short and sweet. What do we take away from this? You just need to design for the 10-foot experience, and that means making the navigation remote-friendly, utilizing those built-in media buttons if they're available, providing button highlight states that show exactly what has the focus, making sure that the screen flow is clear and functional, and reducing the static text, increasing the font size at the same time. You also need to design for the TV hardware, which means targeting 1080p in general, embracing that static landscape mode, allowing for a safety zone around the visual elements to account for possible overscan issues, and understanding that TVs still, even today in this day and age, display color differently from mobile devices. And then use responsive design. That is, design for key aspect ratios rather than specific resolutions, and then adjust on the fly to tailor the experience to the hardware that's currently in use without having to create multiple executables. Spend some time in fine-tuning the input mechanism so that it works in context, and adjust the tutorials and help screens accordingly. And that's it.